Hi, welcome to Blender Tutor. I'm Tom, and today we're going to go over creating a fluid simulation in Blender 2.91 with Mantaflow. Now this past week I did a poll on my YouTube channel asking what you guys would be interested in seeing next. At the time when I started working on this tutorial, Mantaflow Fluid Sim was in the lead. Now it's tied with Soft Body Dynamics tutorial, which I will be doing next week. And then after that I will do an animation node tutorial. Those are all coming in the next month or so. Here's a few animations I created with Mantaflow in the past year. Now this one right here is using Mantaflow, but it's also using the particles, the particle generator in Mantaflow, which lets you create like foam, bubbles, spray, all separately, so you can add more detail to the fluid. This one I was trying to go for like a melted metal look, kind of like the golden crown in season 1 of Game of Thrones. But anyway, let's just get into it. So really quick, before we go into like all the details of everything, I'm just going to show you the quickest way to create a fluid sim really quickly in Blender. So the quickest way is to just take your default cube or any model that you have in your scene, hit F3, type quick, and then choose quick liquid. And that will automatically set up a fluid sim. So it'll add a domain. It'll turn whatever model that you selected into the fluid object. So that'll kind of be where the fluid's being created from. And now you can see you have these like blue dots in here. And if you press the space bar, it'll just play. It won't show a mesh yet, but this is kind of like a little preview of what the fluid will behave like once you bake it. And the cool thing about Mantaflow that we didn't get in the previous fluid simulator in Blender is you do get this preview option, and it's a really quick way to see what your fluid's going to behave like before you spend a long time baking it. Now when it creates the default domain for you, it's going to have like a pretty low resolution fluid, so it's going to look very like thick and blobby, and it won't really behave exactly how you'd want, but you could just easily type in a new number and it'll update. And now if you press play, you can see there's more particles and the detail is finer. And what's happening here is we have under cache in our physics tab, this is the replay type of simulation. So there's a few different like modes basically. This is the one that shows you a preview and it happens in real time. So you press play and it calculates as it's going. You can't actually bake it. Like it will bake to the folder, but you can't like bake it all at once. You have to bake it as you're playing it. But that is like a good way to quickly see how something's going to act. You could also really quickly let's bring in a UV sphere, scale that down a little bit. I'll bring it down. And now you can just, in the physics tab with this sphere selected, click on fluid. Let's choose an effector, which is basically turns it into a collision object. We'll go over these settings in a bit, but for now you can just turn this up to like 12. And now let's update our scene again. Just change this number and then change it back to whatever you want. Press play. And now you can see the fluid is interacting with that object we just added. Now if you want to see what it's actually going to look like with the mesh, you can go down to mesh right here and just turn that on. And you could already see it has a mesh now. And let's even turn off our cube. Now press play and it'll go a little slower because it's calculating the fluid sim and the mesh on the fly. But now we can see what our fluid's going to look like. And even at just 64 for the resolution, this is looking pretty okay. I will say you're probably going to want to render this in cycles instead of EV because I just don't think EV looks very good for fluid or any kind of like glass material. Now, if you were just doing like this as a metal material or some other kind of non-transparent fluid, EV is totally fine, but I just think cycles is going to look better when you are doing a transparent fluid like water or something like that. And it even gives you a default water material, which I think even by itself, it looks pretty good. Obviously this looks really boring, so we could just pop in an HDRI. And I would recommend experimenting with different HDRIs because each one's going to give you a vastly different looking fluid. Since this is kind of hard to look at right now, let's just go to film and then turn transparent on. Now we'll just see our water. But yeah, like it's super quick to get into the fluid sim and just mess around, and it is a lot of fun. Another thing you could do really quick, let's just bring in a cube, bring that down. I'm going to scale it, hit Shift Z to scale it on everything but the Z. And we'll go into the physics tab, fluid, and turn on flow. And you can see, since Blender uses Mantaflow for both smoke and for fluid, it's defaulting to smoke right now, but we could change that to liquid right here. And then flow behavior, change that from geometry to outflow. You could turn sampling substeps up to 12. Once again, we'll go over that shortly. But what this is going to do now is it's basically an outflow object for your scene. So any fluid that interacts with this object is going to be removed from our simulation. Actually, since it's still baked from the previous simulation, we'll just need to reset that again. Now press play. And you could see that all of our fluid is disappearing once it comes in contact with our outflow object. Now, obviously, that's not something you always need, but it's just a useful tool to have. All right, well, so now let's actually go a little more in depth over this stuff. So let's just select everything and delete it. So let's bring in a cube. You can scale that by 2. I'm gonna bring it up by 2 on the Z. And let's name that domain. And as you might be able to tell, this will be our domain object. That's basically where the fluid sim will take place. The fluid sim only takes place within the domain. And the domain is one of 2 objects that you absolutely need in your scene for a fluid sim to work. The other thing you're gonna need is some kind of an inflow object for the fluid. It's basically any kind of mesh that will be bringing the fluid into the simulation. So let's choose an icosphere, scale it down a little bit. I'm gonna bring it to the top, and I'm just gonna rename it to inflow. And now let's go to the physics tab with our domain selected, hit fluid, and choose domain. And also you'll see domain type right here. By default, it's gas. That's where you do your smoke simulation and fire simulation. We hit that drop down and just choose liquid instead. Once you do that, you could scroll down to the cache setting and turn on is resumable. Basically, that just means if you pause it while it's simulating, you could start it back up again later and resume as long as you don't change any of the settings. Let's also select our inflow object now. Go to fluid and choose flow. You're going to want to change the flow type from smoke to liquid. And then this, currently it's set to geometry. You can see there's 3 different settings. Basically, geometry is what we'll probably use for this tutorial, and that just takes the volume of your mesh, converts it to a fluid, and it will just simulate basically just based on that amount of fluid. But if you change it to inflow, it will be constantly bringing fluid into the scene based on that mesh. So now we could play, and you can see it's just constantly pouring more fluid in. And it's just going to start filling up our domain. But like I said, we'll just do geometry for now. The other setting you're going to want to pay attention to is the sampling substeps. It's set to 0. I would recommend turning that at least up to 12, but depending on your simulation, you might want to even bring it up higher. Here's an example of a fluid sim I did earlier this year with Mantaflow, where it didn't learn to use this setting yet. And you could see my water faucet just looks like blobs of water coming out instead of a constant stream. And basically because I had turned up the velocity of the inflow object, it's coming out too fast, and the simulation isn't actually simulating a constant stream. It's only being updated once a frame, and since the fluid was moving too fast, and I had used an icosphere as my inflow object, it just looked like a bunch of blobs coming out instead of a constant stream. So by bringing up your sampling substeps, that will smooth out the simulation. So those are the 2 components that you absolutely need to have a fluid sim with Mantaflow, but there are 2 other things that we could add. One of them you've already seen, an outflow object. Other one that you've seen is the collision object. So let's just bring one of those in. And the other thing you could do is it doesn't have to be a static object, so you can actually animate it. So, and that goes for your inflow object as well, but since this is just going to be the geometry mesh, it's just a single like splash of fluid, so we don't really have time to animate that. But with this, I could start it like over here. I'm going to actually go ahead and go to the physics tab, click fluid, select effector, and it's set to collision. There's also a guide type, which I won't be going over in this tutorial, but maybe in a future tutorial I could go over like more advanced things in Mantaflow. You're going to want to turn up the substeps on this as well. And so on frame 1, I'll just add a location keyframe and then like go to frame 15, let's say, and I'll bring this on the Y over a little bit, add another keyframe, and now let's change the resolution number and the divisions in the settings for the domain. That'll reset our simulation. I also see that I actually still have my cube from my previous example, so I'm going to delete that so we don't have that mysterious fluid at the bottom. And now it's gone. So now if I play this, you could see that the fluid is interacting with that effector object, then it's dropping to the bottom. So now that you've kind of seen the basics of Mantaflow, let's actually create a little more in-depth thing. So we could actually change it in the cache settings on the domain from replay to modular. And what that will do is let us bake every part of the simulation in separate steps. So you're not wasting a lot of time like going frame by frame watching it just to find out at frame like 30 that it messes up. You can just quickly bake the fluid section first, and actually, before I do that, go down to cache, and by default it will cache the entire 250 frames of your timeline. So if you just want to see a really quick test bake of your fluid, just bring that down to like 60 frames, and also make sure you turn on is resumable. And now you can see I could resume this bake, and I'll let that go really quick. Okay, so now that that's baked, I could just play it really quick. And I'll bring my timeline down to 60 frames as well, so I can just kind of watch it loop. Cool. Now 32 for the resolution is actually really low. You're probably going to want it like 64 at the lowest, but realistically you're going to want to bring it up to like 90, 120, and even higher depending on the scale of your simulation and your scene. Now, another reason you might want to turn up the resolution of your domain is because the lower the resolution is of your fluid, the less likely it is to interact with a collision object. So since this collision is, pretty big compared to the scale of the fluid, it seems to interact just fine. But let's add a Suzanne head. I'll get rid of this. I'm just going to bring it down to like the bottom of our domain. And then I'm going to turn that into a collision object real quick. And I'm going to bring our domain, I'm going to free the cache there, bring that down to 32. And then I'm going to bake it really quick. And you can see it is interacting just via the particles, but now let's bake the mesh and see what it actually looks like. So I'll turn on mesh. Just a few settings real quick to go over here. You have your upres factor, which is kind of like subdivision surface modifier for your geometry in meshes. It'll add some subdivisions to your fluid. So a 32 division domain in Mantaflow with a upres factor of 2 is going to actually look higher resolution than a 32 resolution in the older version of the fluid sim. Let's go ahead and bake that mesh and see what it looks like when it's interacting with this. And so yeah, you could see it is collecting on top of the monkey head, but you could see it's kind of clipping through parts of it. It's not fully interacting with it. And the reason is the resolution is just too small. It's just too low for it to properly interact with this mesh. Now here is an example of this is probably one of my first Mantaflow fluid sim tests that I did earlier this year when it first came out. And I don't exactly remember what the resolution of the domain was for this one, but you could tell just by looking at it that the fan blades at the bottom aren't really interacting properly with the fluid. And that's because they're way too thin for the resolution of this domain. So I would either need to have made them thicker so that they would more easily interact with the fluid, or I would have to raise the resolution of the domain. So now let's go ahead and create just a full Mantaflow fluid sim, including like the foam and the spray and bubble particles, just so you could kind of see how it all works together. So I'll bring in a new cube, scale that up by 2, make it a domain, and I'll do something like 80 for the resolution. So I'm going to make it modular. I brought it down to 96. I'll make it is resumable. And before we do anything else, you could open this particles tab and let's just turn on all three of those. Now, my computer actually is getting a little old now, or at least the CPU is, and it's kind of bogged down when it's trying to render a higher resolution fluid sim with the particles. It'll get maybe up to 3/4 of the way through rendering, and then it'll just freeze because it cannot handle all of the geometry in the scene. Part of that is because by default it's adding just way too many particles for my computer to handle, so you can lower the maximum amount right here under wave crest particle sampling. The maximum per cell is 200. I'm going to bring that down to like 40 and then lower the 40 down to 20. And I'll also turn on mesh. I'll leave these settings for now, but you want to turn on use speed vectors, and that will allow us later to add some motion blur to our fluid and to the particles. And before I go any further in the tutorial, I do want to just quickly go over this diffusion tab right here. You could turn that on and it has a few preset options. It has water, oil, and honey. Now I just chose each preset and rendered it in the same scene so you could see them side by side. And you could see from water to oil to honey, they appear to be a little more viscous and, thick basically, so they don't splash around as much. They look a little stickier and thicker, but just keep in mind it does have some of those presets already, and you could even alter them even more. So if you just click on here, by default it is set to water, so I could change it to oil, and you can see it changes some of these numbers. You go to honey and it changes them even more. I'm going to keep it as water for this tutorial, but I would highly recommend you play around with that to get different looks. I messed around with the diffusion setting when I did the skull with the melted metal. You could even make a new preset by clicking on this tab, hitting the plus sign, name it something you want. All right, so now that we have our domain here, and I would recommend you rename it to domain. I'll just bring in a cube, scale it down, bring it up here, and I'll call that inflow, and then I'll bring in a cylinder, bring it in the corner underneath there. I'm just create whatever you want, just kind of like a sample test scene, and then make sure to add in fluid, effector, collision, and turn your cube, the inflow, into an inflow object. So to go to flow, change it to liquid. I'm going to keep it at geometry, and I'll bring in like one more cube, and I'll turn that into an effector as well. So the first thing we'll do once you have all your objects in the scene is let's just go ahead and bake the data for the fluid particles. And once that finishes baking, we can go ahead and play it. And everything seems to be behaving how we would want it. So the next thing we'll do with our domain selected is go down to the particles tab, and we can bake the particles. And you won't necessarily see a difference at first. Once that finishes baking, you might see more particles in your scene, but it won't be an immediately noticeable difference, other than maybe you could see some like splatter and everything from the splash and foam particles. You'll see more of that once we bake this into a mesh. So now let's go down to our mesh setting and bake mesh. Cool. And now that our mesh is done baking, we can go into like solid view and watch that. I would also say maybe turn off our inflow object mesh visibility. And obviously that's going to be pretty slow to play since it is a pretty high resolution. We'll also shade smooth on the mesh. And if you did that quick fluid at the beginning of this tutorial, that will give us a basic water material. So I'll just add that to the domain. And now if I go into rendered view, it's kind of hard to see with the particles in there. So with the domain selected, go to your particles tab, and you could just turn all of these off in the viewport mode. And now go to rendered view and see what that looks like. And it looks fine. It looks kind of how we would imagine, but let's go ahead and add some particles in now. So I would recommend icosphere and bring it down to 1 for the subdivisions. And I'll just move that over on the X, kind of out of our scene. And we're gonna have 3 different types of particles. You're gonna have splash. You can actually go to your mesh, your domain mesh, and see them. So you're gonna have spray, foam, and bubbles. So let's do foam first. So with our icosphere, I'm gonna name that foam. I'm gonna shade it smooth, scale it down. Under material, I will give it that basic water material, but then hit the number next to the name. So it'll create its own copy of the material. And I will just rename that to foam. Now let's go to the shading tab and let's do one thing. So this is a really simple material already, as you can see, but what we're gonna do is bring in a mix shader and a diffuse. And let's plug in our glass and the diffuse shaders into this mix. And then you can bring that up to surface. So it'll kind of look like a foamy material now. It's like kind of see-through, but not fully. That'll be a good foam material. Then we could duplicate our foam and rename it to bubble. For that, let's change the material type. Let's go back to the original water material, hit the number again, and rename that to bubble. For that, I will just change the IOR to like, since it's a bubble, I kind of view it as like a bubble of air, which technically the IOR, which is the index of refraction, is 1 for air, but just so it's a little more visible in the scene, I'm gonna keep it at like 1.1. And you could change this color too, like maybe make it a little darker for the volume and a little more colorful. All right, and then the last one, just duplicate that one more time. Let's name that to spray. And this isn't super necessary if you don't want to include this particle, but I just wanted to show you how to make it if you wanted to. So it's spray, let's go to the materials, choose water one more time, call it spray. And really, you don't have to change the material at all, so we didn't have to rename it. I just kind of do that for each object. But you could, since it's just a spray of water, I will leave it as is. Now we could go to our mesh, our domain mesh. Let's maybe go a little earlier in the simulation. And right now I have particles turned off, so I'm gonna go to that particle tab. I'll turn them on one by one. So let's do foam first. So I'll turn that on and see anywhere where these dots are basically, that's where they're going to appear as the mesh. So change it under render, change it from halo to object. And then you could just choose the foam icosphere, and now you can see they're showing up in the scene. And the size of them in your domain are going to be based on how big they are over here. So you could scale them up and that'll scale it up in your scene. I actually don't want them to be any bigger than they already are. And now that we know that's working, we could turn it off in the viewport. Now let's do bubbles, turn that on. You can see where they're showing up. Do the same thing. Object, bubble, and then turn that off. And then for spray, do the same thing. So you can turn that on, change it to object, spray. And now I'll just bring my camera to this view. I'm gonna move those particles a little more out of the way. And then I might even just add a plane at the bottom, just so that has a floor now. So now let's go into rendered view. And they're actually not showing up in a render view because they're off in the viewport. But if we render this real quick, and before you render, make sure to turn off your inflow in the render tab. Cool, so that is rendered. And now you could see we have our like bubbles, spray, foam all down here. But if you want to improve the look of that, we could actually go into the compositing tab and add some motion blur. So there's one thing we're going to actually have to do. Go to your view layer properties tab on the side and turn on vector under the render data or under the passes. And I'm going to reposition this camera a little bit. And I'm going to render that real quick and we'll be right back. Okay, and once that is rendered, let's go back to our compositing tab, add in a viewer node. So if you just hit Control Shift and click on the render layers node over here, it'll add your viewer node right there. You can move the background image just by clicking in the center. There's a little X, so I'm going to drag it over here. I'm going to scale it down just so we can see it in the screen easier. And now let's go to filter vector blur and add that in. And so you're gonna have to put an image to image. You're gonna put depth to Z, and then you'll put vector to the vector down here. And it'll take a second to update, but you can see there's some motion blur in there now. And I turn on curved usually. And if for the blur, if 1 is too much, you might wanna lower that. I think I usually set it to 0.5. But you might want to play around with that a little bit. Now, I do want to show you what happens, at least if you have an older system and you have a lot of particles, since this is, I believe, set to 80 for the resolution of the domain. That's not the crazy highest resolution, but it's enough where when you have a long enough animation, it's going to add in a huge amount of particles. Like right here, I have all the particles turned off in my scene right now, but if I were to go and turn them on in the viewport, you could see how many particles there really are in this scene now and how much more resolution there is. That's going to add a lot to your render time, and that's going to sometimes completely slow down, freeze, or crash Blender. I know this is using the CPU to render all of this, but in the scene itself, but depending on how you're rendering GPU or CPU, you might have some limitations there as well. And I don't know if RAM comes into play either, but if I had tried to render this frame now, since this has tens of thousands, if not hundreds of thousands of particles per frame, and they're each being rendered as mesh objects, which each have, I think even the lowest resolution for the icosphere, between 10 and 20 vertices per mesh object. That is a lot of resolution in your scene that it needs to calculate. You can see right now while I'm trying to render, it's updating object flags. It usually stays on this, the more particles in the scene, the longer it stays on this. So keep that in mind. My computer is getting a little too old to be able to do that. So I am going to have to update my CPU and probably my graphics card soon as well. So I'll be able to do more in-depth simulations and tutorials, which, by the way, if you would like to help me get to that point, you can support me on Patreon, where the first thing I'll be doing with that money is putting it towards a better system, which I'll use to be able to create better tutorials. I'll be able to render out animations faster, and I'll be able to get my videos out faster, because even just editing these now is slowing down my computer quite a bit. If you do become a patron, depending on the tier you select, you'll get access to the project files for these tutorials. There's material download packs. I have 4K resolution wallpapers for phones, and you'll get shoutouts in my tutorial videos. So consider supporting me on Patreon. And also, if you're getting something out of this tutorial, make sure to like the video and subscribe for more Blender tutorials. So that frame finally finished rendering, and just for an example of how long it would take, this single frame took 6 minutes and 17 seconds to calculate all the data and then render the frame itself. And I'm only using, I think, 128 samples in cycles for the render. So without having to calculate all that data, this frame should have rendered in under a minute. But because it has all that data and all the particles plus the vector movement to calculate, it took way longer. So yeah, that is the tutorial. Thanks for watching, guys. If there's anything I missed in this tutorial that you want to know about the Mantaflow Fluid Sim, comment below to let me know what I can do in a future tutorial. I would like to do a more advanced fluid sim tutorial and kind of go over like a actual use case for it other than just the basics like in this tutorial. But if you have a specific idea you'd like to see from me, make sure to let me know. And yeah, I might need to hold off until I could get a faster system before I do a more advanced tutorial, but I would like to do that. Hopefully 2021 is the year. So thanks for watching, guys, and I'll see you next time. Bye.